Thank you, Mike. Good morning, everyone. Before I start on Healthy Trees, Healthy Future, I just want to give a little bit of a history lesson, I guess, on some of how we've handled new pathogens that have arrived in the country previously. So the first one is Nectaria fluke canker. It was confirmed in 2003. It really did have us scratching our heads. The pathogen was noted on spruce and fir trees in the northern hemisphere. It was noted as a wound invader. It wasn't a serious pathogen at all. It arrived in New Zealand in the southern hemisphere for the first time on radiata and caused considerable damage and really was serious concern to forest growers in the southern South Island over that period. Caused severe malformation of the stem, and you can see by that picture on the right there, that's an extreme example, but it really was serious. But through research, we came up with findings that allowed forest growers to alter their silvicultural regimes, and now the pathogen really isn't causing much damage at all. It's a curiosity disease, as Peter Oliver aptly describes. So, it took about 6 years to really control and manage that disease. Dothostroma needle blight, it arrived in 1962, it was confirmed in 1964, causes severe defoliation of pine trees, as I'm sure most of you know. By 1966, we had an operational control method for that, and we were routinely spraying trees with copper. Breeding and spray applications research has certainly helped manage that disease in recent times, and we've gone from spraying at 50 litres a hectare down to 5 litres and sometimes 3 litres a hectare. So great efficiencies made, and another success story. Red needle cast, that's a slightly different story. It was first noted in 2005. This is a forest on the East Cape of the North Island, causing medium severe defoliation. When I looked at this stand then, I thought there was something unusual happening. We took lots and lots of samples, didn't isolate anything new in terms of pathogens. So we just put it down to some odd year, something's funny, but it'll come right. 2008, that's that same stand that I photographed previously, severe defoliation. We took one look at it, Margaret, Dick and I, and said, this is something new, this is something different from what we've seen. Went back to Rotorua the following day. MPI, MAF in those days, and the forest owners were readied, and by Monday we had started an investigation response, so it can happen that quickly. We hadn't really seen, as I say, anything like that before. Just shows you the two different pictures. So when it was confirmed in 2008, it was confirmed as a Phytophthora. The Phytophthora was new to science, something that would never have appeared on any risk list or anything like that. The trade implications were of greater concern than the productivity loss. Forest owners were concerned that China might ban our log imports because of the ability of our logs to carry this pathogen over there and establish over there. So really for the first 3 or 4 years, we determined the risk to trade, and through research determined that this pathogen wasn't a risk to our trading partners, and we published that. We presented results in a conference and then published those results. So that issue was mitigated. Then we focused on how to control the disease and increase productivity and avoid productivity loss from that. As Mike said, there's 4 foliage diseases on radiata pine in New Zealand: Dothostroma needle blight, Cyclonesma needle cast. We call it Phytophthora needle blight now, because we know that blight is caused by a Phytophthora, and red needle cast. So what do we do to control these diseases? This is where the Healthy Trees, Healthy Future program comes in. And this is all about Phytophthora diseases and trying to future-proof our forests from the threat of Phytophthora diseases. And really what we tried to do was inoculate 3 different hosts, pine, apple and kauri, with a range of Phytophthora, and look at the responses that those inoculations elicited, and from that we could understand and gain knowledge about how the tree could defend itself from those Phytophthora threats. That was a pretty lofty aim at the start of the program. We didn't get there in terms of doing all the crosses between all the Phytophthora, all three hosts, and roots and foliage, but we got some of the way, and I think the program has been successful despite not meeting those goals. So I'll go into the first part of the program, and that's looking at epidemiology of Phytophthora pluvialis and how it causes red needlecast, how they have this pathogen has the ability to cause epidemics. And what we've found is that it's polycyclic, it causes multiple disease cycles per year, and that can happen really, really, really quickly. The chart on the left can show that disease symptoms can happen 5 days after the pathogen actually infects foliage. That's really, really quick. Second infection can occur in about 20 days. So from that, you can understand that this disease can build up really, really quickly. And I've seen that in the field where stands have gone from completely green to pretty much red within a month. So that's what we're sort of battling against. That's for on radiata. On Douglas fir, we did studies where we matched climatic conditions in Oregon, where Phytophthora pluvialis comes from, and conditions in New Zealand. And you can see from that, probably can't see from where you are, but the conditions, some of the conditions match quite closely in terms of rainfall and temperature. What we've found, interestingly, is that in New Zealand, the amount of pathogen in the foliage is significantly higher than it is in Oregon. Maybe in Oregon, because the pathogen's native to Oregon, that the hosts have, evolved with it, and they have the ability to fight off the pathogen, and they're sort of in balance. But in New Zealand, because Phytophthora pluvialis is a new introduction, Douglas fir, maybe we've got a narrower genetic base. The pathogen has much greater ability to infect hosts than in Oregon. Again, so just repeating what I've said really, that there's a lower prevalence of Phytophthora pluvialis in the Pacific Northwest than there is in the South Island of New Zealand. And mild winter temperatures appears to be the key driver of Phytophthora pluvialis in New Zealand compared with Oregon. We found pretty much the same in radiata too. Lower temperatures, lower winter temperatures are a driver for red needlecast development, or limit red needlecast development. That's one of the, I guess, the keys to managing the disease is knowing when to spray. And higher mean winter relative humidity favours pluvialis. So mild winters, high humidity, you could well get a disease outbreak. So I'm now going to pass on to Ellen.